Okay, today let's talk about the section 8.3, Trigonometric Equations. Okay, so trigonometric equations is an equation with trigonometric functions. So we already know that x squared equal to 1, x cubed plus x equal to 2. We have some polynomial functions. Now we may have a function with trigonometric function. An equation with trigonometric function. For example, we have this 2 sine theta minus 1 equal to 0. The first question is theta pi over 4 a solution? Okay, so it's a straightforward question and a straightforward answer. Is it a solution? You just plug in and see if it satisfies the equation. Yeah. So you evaluate the left-hand side at pi over 4. Sine pi over 4, remember that sine pi over 4 is a root 2 over 2. Two times it, 2 denominator 2, they're cancelled. It becomes a root 2 minus 1. And we know that the square root of 2 is not equal to 1. So this difference is not equal to 0. Since it's not equal to the right-hand side, so theta equal to pi over 4 is not a solution. Okay, and of course you have the answer no. Then second, we will give you a right answer. Is theta equal to pi over 6 a solution? Okay, so you are going to repeat this process and recall that sine pi over 6 is 1/2. 2 times 1/2 is 1, and 1 minus 1 is 0. So we can claim theta equal to pi over 6 is a solution. So the trigonometric equation just have this special function. In order to evaluate or to find the solution, you need the sufficient knowledge about the trigonometric functions, right? And here, not like the polynomials. Polynomials, for example, you have x equal to 1, x equal to 2 as the solutions. Possibly that's it, and maybe that's all the solutions. But for the trigonometric functions, we know that the trigonometric functions are periodic. So here, when you have theta equal to pi over 6 as a solution, if you let theta equal to pi over 6 plus 2 pi plus 4 pi or minus 2 pi minus 4 pi, it's a periodic, so you can have 2k pi here. When theta is pi over 6 plus 2k pi, you evaluate the left-hand side. Since 2k pi is a period, when you compute the sign, you can just ignore it. And we just know that 2 sine pi over 6 minus 1 is equal to 0. So what we can say, we say theta equal to pi over 6 plus 2k pi is also a solution for any integer, positive, negative, or 0, for any integer k. So because of the periodicity, the trigonometric equation may have infinitely many solutions. So this is a serious difference. Okay, so let's see the example about the complete solution set. Solve the equation. cosine theta equal to 1/2. Solve the equation cosine theta equal to 1/2. Well, cosine is a periodic function, so basically we only need to solve it in one period and apply the periodicity. So here there is a trick to select one period. What is one period? Whenever this interval, the interval inside domain has a length 2 pi, it is a period. Of course, you can select from 0 to 2 pi. That's the regular selection. That's a regular selection. But you can also select this one. You can also select the interval between negative pi and positive pi. Select this one as an interval, as a one period. Why? Because it's symmetric, and the cosine is an even function. Remember, cosine of a negative x is cosine of x. So what is the advantage? Let's see, how do we solve it? What is the advantage? Here, cosine pi over 3 is 1/2. From the table, we know that the cosine pi over 3 is 1/2. And then by this even property, even function property, so it implies cosine negative pi over 3 is also equal to 1/2. So it's like this. You have 1/2 here. You draw the horizontal line, you intersect this point, and it's a symmetric point. Okay, so you have the right and the left point. They correspond to pi over 3, negative pi over 3. Once you find these two solutions, you're going to add them with 2k pi, the integer multiples of 2 pi. So the complete solution set is theta. Theta is pi over 3 plus 2k pi, or theta is negative pi over 3 plus 2k pi, where k is an integer. Okay, it's an integer. So how do we get the answer? We first find the 1. This is the first step, find the 1. And second, we add the negative sign. And then we put 2k pi. So this is the advantage of the selection of domain negative pi to positive pi. Okay, so if you don't choose this domain, you have to figure out what is this point. This point is 5 pi over 3, but it takes some argument why this is 5 pi over 3 if you don't memorize the value. But here we only apply the even function property. So find one angle inside the first quadrant and then put a negative sign to get its symmetric solution. So this is step 1, and get step 2, and then plus 2k pi. For all the cosine function, you can do this trick. Okay? You can always do this. Okay, so this is the special thing for the cosine. For sine, For sine, the thing is the following. Sine function has one. A sine is an odd function, so you cannot say just we'll have one point, put a negative sign to get the other point. That's not correct. That's not correct. But the sine function has sine theta is equal to sine pi minus theta. So it's like this. If this angle is theta, this angle is pi minus theta. So this is theta, this is going to be pi minus theta. I demonstrated here. Actually, in the bottom part, it is also correct. Okay, so don't worry where it is. This theta can be anything. Okay, so for the sine theta equal to 1/2, we know sine pi over 6 is 1/2. Okay, so you find one angle, and then you directly get sine of pi minus pi over 6, which is sine 5 pi over 6 is 1/2. Okay, so from here, you get this step, you get the 5 pi over 6. This is the second number you need, the second angle you need. Once you get the first angle, second angle, the complete solution set is theta is pi over 6 plus 2k pi, or theta is 5 pi over 6 plus 2k pi, where k is an integer. Okay, so that's the computation for the sine and the cosine, the simple one, right? Okay. Solve the equation 2 sine theta plus square root of 3 is equal to 0. Here we don't want complete solution. We just want solution in the required domain. Theta is between 0 and 2 pi. The first two examples are the complete solution without restriction of a domain. Here we just solve the equation over some required domain, given domain. Okay. So of course here we just do some algebra to simplify it. So we move square root of 3 to the right hand side is negative square root of 3, and divide the equation by the coefficient of sine theta. We get this. Here is the trick. We remember that we normally just memorize the sign for the positive value. So we know what is the sine square root, what angle give us sine equal to square root of 3 over 2. So sine pi over 3 is square root of 3 over 2. But it's positive without negative sign. We check that the sine function is an odd function. So sine negative is negative sign. So when you have this angle with negative value, you first find its corresponding equation with positive value. So sine pi over 3 is equal to root 3 over 2. Then theta is going to be negative of this angle. It's because you see here sine negative pi over 3, by the odd function property, you can move this negative sign forward. You move this negative sign forward. And then you recall that sine pi over 3 is a root 3 over 2, so you get it. Okay, so that's all. That's one angle. Whenever you have this angle, pi minus this angle, be careful, it's always, remember here, we use pi minus it. Pi minus it, pi minus negative pi over 3 is a pi plus pi over 3. It is 4 pi over 3. Also gives us sine equal to negative square root of 3 over 2. Okay, so it also gave us this one. And you have one, you have the second one. But be careful, here we only want the solution in this domain. This is one solution, this is second one solution. This second solution is already in it. So we don't change it, so we will keep this here. But the first solution is not inside. We're going to add a proper multiple of 2 pi. You possibly, here's negative, so you possibly will add, let's check. If you add 2 pi, just add 2 pi, you will get 5 pi over 3, okay? So 5 pi over 3 is inside the 2 pi, then that's a second equation, a second solution. That's the second solution. So if you add 2 pi, it's still not inside this domain. You add 4 pi. You check. So you first add 2 pi and add 4 pi, add 6 pi. Whenever you make it inside the required domain, and you stop. If you don't get the answer in the domain, you just continue this addition or possibly subtraction. You may add 2 pi or you may subtract 2 pi. Okay, so we first get a solution. It is a solution without this requirement. Once you get one angle, you use pi to subtract that angle, you get the other one. Okay, so first one with the equation you get with the property you get second one. The second one is already in the given interval, so it's fine. So you just copy it here. Then you have to manipulate your first solution by the periodicity 2 pi plus or minus proper multiples of 2 pi. You're going to plus or minus proper multiples of 2 pi. It depends on what angle you choose, you find here and what domain you need here. Okay? So for example, let's say if this problem we have the same equation but we require the theta between 2 pi and 4 pi. 2 pi and 4 pi. And we get negative pi over 3, we get 4 pi over 3. But they are both not inside this domain. Now, how do we do that? We will add, if we add 2 pi, we get 5 pi over 3. It's not enough, so we're going to add 4 pi. It's 11 pi over 3. And here, this is also not inside the domain, so we're going to add 2 pi. We'll get 10 pi over 3. Okay, and then these two angles are the solution in the required domain. These two are the solution in this domain if we choose the equation but with this domain. So you always first get the solution and then you do the proper multiples. Okay, so I hope I make this clear. The domain the given domain is not always from 0 to 2 pi. Okay. Okay, so now let's say sine 2 theta equal to 1/2. Theta is between 0 and 2 pi. So the tricky thing is this 2 theta. Let's try to study it. We are talking about sine of 2 theta, so we consider 2 theta as one angle. 2 theta itself is a one angle, so we just let x be 2 theta. If x is 2 theta, then sine x is 1/2. Okay, so and theta is between 0 and 2 pi. What is the range between what is the range of x? You just multiply this inequality by number 2. So you multiply this inequality by 2. 0 times 2, theta times 2, and 2 pi times 2. And 2 theta is x. So x is between 0 and 4 pi. This is the given domain. X is between 0 and 4 pi. It covers 2 periods. You see here, this is 4 pi. It covers 2 periods. Okay, so now let's just check. Sine x is 1/2. So you first get x is pi over 6. Sine pi over 6 is 1/2. When you have pi over 6, you use pi minus pi over 6, 5 pi over 6. So sine 5 pi over 6 is 1/2. Okay, so then what we get? We get the complete solution. The complete solution is pi over 6 plus 2k pi, or 5 pi over 6 plus 2k pi. So this is complete solution, but we need the solution in this domain. So let's check 0 to 4 pi. So first, pi over 6, it is between 0 and 4 pi. 5 pi over 6 between 0 and 4 pi. And next, you're going to add, not subtract, because if you subtract 2 pi, you will get a negative number. Okay, so add 2 pi. Pi over 6, add 2 pi. 5 pi over 6, add 2 pi. But you cannot add 4 pi, because if you add 4 pi, the value will exceed 4 pi, will be greater than 4 pi, so it's outside of the domain. Okay, so there are 4 solutions. There are 4 solutions inside the required domain. So x can be this, and this is a 13 pi over 6. This is a 15 pi over 6. Okay, so they are x. They are x. What is a variable? Variable is theta, not x. X is something you create, not the given one by the definition, by the problem. So x is 2 theta. So 2 theta is this, 2 theta is this, 2 theta is this, and 2 theta is this. What is theta? Theta means you just divide everything by 2. So pi over 6 divided by 2, pi over 12. 5 pi over 6 divided by 2, 5 pi over 12. 13 pi over 6 divided by 2, 13 pi over 12. And here 15 pi over 12. Here you divide by 2, you get a 0, 2 pi. Okay? So we first insert an x, and then we go back to our previous type of problem. We don't want this coefficient here. if we have coefficient here, we will be confused about the domain. So here the domain includes 2 periods. Once the domain includes 2 periods, you will possibly add 2 pi, even though the points are inside. So you see here, this pair is already inside the region, and this pair is actually inside the next. Whenever you plus 2 pi, it means it's in the next period. Okay, so this is in 1 period. This is in 2nd period. Okay, so it's just because here you have 2 periods. X has 2 periods. Okay. Solve the equation tangent theta minus pi over 2 is equal to 1, and theta is between 0 and 2 pi. Same thing. We want to simplify the internal expression. We don't want tangent theta minus 2 pi. It's too complex. So let x be theta minus pi over 2. X is theta minus pi over 2. We want to determine the domain in terms of x. So you subtract pi over 2 from 3 sides. Zero minus pi over 2, negative pi over 2, theta minus pi over 2, 2 pi minus pi over 2 is 3 pi over 2. 2 pi minus pi over 2 is the 3 pi over 2. So this is the domain of x, and the tangent of x is 1. Tangent of x is 1. Okay, and then let's see what tangent has period pi. Remember, tangent theta has period pi. Tangent x is 1, then x is pi over 4. That's it. In 1 period, there's only 1 solution. Remember that? Tangent theta in 1 period, there's only 1 solution, so it's a pi over 4. When you have pi over 4, the complete solution set is pi over 4 plus k pi. Here is pi over 4 plus k pi. Okay, now we have our domain between negative pi over 2 and 3 pi over 2. Okay, so we'll have pi over 4. Pi over 4 is inside. Pi over 4 plus pi, you go to right, you go to left. Pi over 4 plus pi, you get 5 pi over 4. 5 pi over 4 is less than 3 pi over 2. You see, 5 pi over 4 is 1.25 pi. 3 pi over 2 is 1.5 pi, so it's less than it. And if you add more, it will be greater than 3 pi over 2. And if you subtract pi, you see here, you go to right, you go to left. You subtract pi, pi over 4 minus pi is negative 3 pi over 4. Negative 3 pi over 4 is less than negative pi over 2. It's less than negative pi over 2. Okay, so it's not. So there are only 2 solutions for x. Here there's also one thing. This contains 2 periods. This contains 2 periods. This is in one period. This is in second period. So you already covered 2 periods, so you stop. Okay, so this is x. What is theta? Theta, so theta minus pi over 2 is equal to x. So theta is, you move this pi over 2 to the right side, so it's a pi over 4 plus pi over 2. 3 pi over 4, or theta is this number. This is 5 pi over 4. 5 pi over 4 plus pi over 2. Right? 5 pi over 4 plus pi over 2, what's this? It's 7 pi over 4. So 3 pi over 4, 7 pi over 4 are the solutions. Okay, so we have some step, almost fixed steps for the computation, for the solution of such equations. We first simplify it and just consider the tangent of x is some number, sine of x is some number, cosine of x is some number. And then we find the complete solution. If there's no additional requirement, the complete solution will be the final answer. If there is a special requirement, you're going to choose proper k so that you get all the solutions in the required domain. Okay, so that's almost a fixed step. Okay. Well, so far we have very simple equation involving the trigonometric function, and possibly the equation could be a little bit complex. For example, we have the quadratic equation involving trigonometric function. So 2 sine theta squared minus 3 sine theta plus 1 equal to 0. Theta is between 0 and 2 pi. So we have this quadratic equation. How do we solve it? In principle, this is a quadratic equation. So we let x be sine theta. X is sine theta, so we get 2x squared minus 3x plus 1 equal to 0. So it's a quadratic equation. For the quadratic equation, we can factor it. We get 2x minus 1, x minus 1 equal to 0. Remember that you write 2 as 1 times 1, 1 as a negative 1 times negative 1. You do the cross product. This 2 times negative 1 is negative 2. 1 times negative 1 is negative 1. The sum is negative 3. So you get a negative 3 here. And then you put x this place, x this place. So it's 2x minus 1. 1x minus 1. 1x is x minus 1. Okay? So from here you get either x is 1/2 or x is equal to 1. This is a solution here, this is a solution here. Right? So we get the solution for the quadratic equation. But we know that our x is sine theta, so sine theta is 1/2, or sine theta is 1. Sine theta is 1/2, sine theta is 1. And remember, theta is between 0 and 2 pi. This is a requirement. Now let's see. Remember, how do we do this? Sine theta is 1/2, then theta is pi over 6, or pi minus pi over 6. You find one answer and you use pi to subtract it. They are both inside this domain. And sine theta is 1, then theta is pi over 2. And pi minus pi over 2 is itself, so you don't write it. So That's all. This is 5 pi over 6 and pi over 2 are solutions. Okay. Okay, so now that's a complete solution. In this computation, you see there's a small difference between 1/2 and 1 when we solve these two cases. The difference comes from, you see, the graph of sine. For the graph of sine, there are two special values. One is 1, the second one is -1. If you have 1/2, -1/2, this type of equation, the value is less than 1 or greater than -1. If you have such equation, you will have two solutions in one period. It can be here, it can also be here. It doesn't matter, it's positive and negative. So for 1/2 or -1/2, sine theta equal to 1/2 has two solutions in one period. Okay, so for this kind of number, smaller number, you have two solutions, one period, and then you add 2k pi, you get all the solutions. But for 1 or -1, sine theta equal to 1 or sine theta equal to -1, these two special cases, you see here, all here, they has only one solution in one period. There's only one solution in one period. Here, sine theta equal to 1, theta is pi over 2. This is one solution in one period and plus 2k pi. Sine theta is -1. If sine theta is -1, then theta is 3 pi over 2. This is pi over 2. This is 3 pi over 2. And then plus 2k pi to get the complete solution. These two are special. They represent those two extreme cases. If you have 1/2, you will have pi over 6, 5 pi over 6, and then for those two different solutions, you add 2k pi. Okay, so I want to emphasize there is a small difference between -1, +1, -1, and other numbers. Tangent in one period, there's only one solution. But for the sine, cosine, for the sine and the cosine in one period, it may have two solutions. It may have just one solution. Be careful. This is important. Okay. Next, let's see some equation involving two different trigonometric functions, and we have to use some identity. Okay, so 3 cosine theta plus 3 is equal to 2 sine theta squared. You see here in the previous examples, even with the quadratic form, we have sine. Then we can use x equal to sine and simplify the equation. But here you have sine and cosine. If you have two different trigonometric functions in one equation, it just means you need some tricks. And here the trick is the following. We are going to use the identity to transform one trig function into the other. So we know that cosine theta squared plus sine theta squared is equal to 1. So sine theta squared is 1 minus cosine theta squared. So we just move this term to the right hand side. Okay, so sine theta squared is 1 minus cosine theta squared. So this original equation becomes 2 times 1 minus cosine theta squared. So it's 2 minus 2 cosine theta squared. You move this to the left hand side. 2 also move to the left hand side. You get 2 cosine theta squared plus 3 cosine theta plus 1 equal to 0. This move to the left, it becomes plus. 2 move to the left, minus. 3 minus 2 is 1. And now you see this like the previous example. You have the quadratic form. So you let x be cosine of theta. So the equation becomes 2x squared plus 3x plus 1. And then you factor it. It's similar to the factorization is similar to the previous one. You just decompose 1 as 1 times 1. And then you get x is negative 1/2, or x is equal to negative 1. Okay, negative 1/2 give the first factor equal to 0. Negative 1 give the second factor equal to 0. Okay, so you get cosine of theta is negative 1/2, or cosine of theta is negative 1. This part, what is the cosine theta is negative 1/2? Theta is, what's this? It's a 4 pi over 3. Oh, sorry, 2 pi over 3. No, not that. 2 pi over 3. 4 pi is the same thing, but let's use 2 pi over 3. Or you have 2 pi over 3, you have negative 2 pi over 3. And here you get cosine. Check here. This corresponds to pi. Theta is pi. And remember that whenever you have an angle, you put a negative sign, it will be the other solution. The problem is that theta is between 0 and 2 pi. This is not in the 0 and 2 pi, so you're going to add 2 pi. You add 2 pi, it is equal to 4 pi over 3. Okay, so the reason I change the first angle from 4 pi over 3 to 2 pi over 3 is the following thing. We memorize the angle of the value of cosine, like 0, pi over 6, pi over 4, pi over 3, pi over 2, and then you see we're going to start here, 2 pi over 3, 3 pi over 4, and 5 pi over 6, and the pi. So we only memorize the value of this first 0 pi interval. And the cosine theta, you will get 1 root 3 over 2 root 2 over 2 1/2 0. And then you get the order but with the negatives. Negative 1/2, negative root 2 over 2, negative root 3 over 2, and then negative 1. Okay, so this is a cosine. You see it down and the negative 1. And sine theta is going to be like this. So it's a 0, 1/2 root 2 over 2 root 3 over 2, and 1, and then going down, root 3 over 2, root 2 over 2, and 1/2, and 0. Okay, and that's the reason I changed the 4 pi over 3 to 2 pi over 3. That's a thing I memorized in this table. This table is very, very important. And also, pi is the unique solution for cosine theta equal to -1. And 0 is a unique solution. 0 is a unique solution for cosine theta is equal to 1. Why I say unique? Because we only include 0, but we exclude 2 pi. 2 pi is here, but this is not in the domain. Check here. So that's why there's only one for cosine theta equal to 1, and only one for cosine theta equal to -1. Here's pi. So what is the solution? Let's summarize the solution. The solutions are 2 pi over 3, 4 pi over 3, and the pi. Here is the solution. Here is the solution. So in this computation, the trigger identity is the essential one. So sine square plus cosine square is equal to 1. It's very, very important. This property is extremely important. Let me get a better picture of the whole page. Okay, so this is a whole page. Sorry. Okay, so you can see the whole page. I wrote something here. It was not in the screen. Okay, so let's see the next example. Solve. Cosine theta squared plus sine theta is equal to 2. Theta is between 0 and 2 pi, including 0, excluding 2 pi. Same thing. We apply this trig identity. Cosine square plus sine square is equal to 1, and here we will get cosine theta square is 1 minus sine theta square. We're going to plug in here. So 1 minus sine theta square plus sine theta is equal to 2. And then we're going to organize it. We move this 2 to the left hand side, it becomes minus 2. 1 minus 2, -1 equal to 0. Okay, and whenever we solve quadratic equation, we prefer a positive coefficient of a square. So we multiply everything by -1. Here times -1, here times -1, here times -1. Okay, so we have a quadratic equation. This quadratic equation, let x be sine theta, then we have x squared minus x plus 1 equal to 0. And we try to factor it. We figure we couldn't make it. We couldn't make the factorization. Then let's check the discriminant. Remember that ax squared plus bx plus c equal to 0. The discriminant is b squared minus 4ac. Discriminant b squared minus 4ac. We have 3 cases. It's greater than 0, 2 solutions. Equal to 0, 1 solution. Less than 0, no solution. the discriminant b squared minus 4ac give us 3 cases. Now let's check here. This b squared minus 4ac, b squared minus 4ac is equal to b negative 1 squared minus 4. A is a 1, c is a 1. Negative 1 squared is 1. 4 times 1 times 1 is a 4. It's negative 3. No solution. So this quadratic equation has no solution. It implies the original answer. Now the original equation. So has no solution. Okay? It's possible, it happens. Sometimes you have an equation but you don't find a solution. Right? Okay, so we finish this section 8.3. It is trigonometric equations. Sometimes the trigonometric equations only involves one trigonometric functions, and you can quickly recall the values and get the answer. And remember that for the cosine, again, equal to a number r, you will have one angle, and directly you get the second angle, negative theta. If you have a sine, you have a one angle, you use pi minus that angle, you get the second one. And then you will add 2k pi plus 2k pi plus 2k pi and plus 2k pi plus 2k pi. If there is a restriction about the domain, you are going to properly choose k in order to make these solutions inside the domain. Right? So that's the complete solution. So normally they have two solutions. If you have plus or minus 1, if you have r is plus or minus 1, one solution, one period. Here is the same thing, one solution, one period. This is like two solutions, one period. Okay, so that's a small difference between these two cases. Okay, so do your exercise. Make sure you understand and know how to find the answers. If you have question, ask me. Okay, we stop here for this section. Thank you.